Good afternoon, everyone. Thank you for making it to this very exciting panel. We've unfortunately had a dropout of the moderator, and Tarunima has very graciously agreed to moderate this discussion. So we'll be discussing responsible AI. The idea is to discuss how we go from principles to proof of concept and actually get stuff done for operationalizing responsible AI. And we'll have a slightly more intimate group, but I think it'll be a very enriching conversation. We're free to begin now. Thank you.
Great. Hello, everyone. Like Mihir just said, I have now stepped in as a moderator, but I also have a fair bit of things to say for myself. So the way we'll do this is we'll go around this panel. We'll do introductions, 5 minutes, and opening remarks. I think we all come from fairly different sectors, not necessarily sectors, but different concerns within our AI given our professional backgrounds. So I'll start with Mr. Mohit Kapoor, who's the Group CTO at Mahindra Group. So over to you, please.
Thank you very much. I think the Mahindra Group, most of the audience is from India, is in automobiles, finance, tractors and farm machinery, real estate, logistics, many other businesses. Security and safety by design, and now, of course, privacy by design, is the bedrock of how we've been working on this. We've chosen 3 basic principles on AI security as well. One is around ethics, responsibility, and then security. That it has to be ethical use of AI, and we hold ourselves, even before AI, at the most apex ethical standards, and that remains to be the bedrock foundation of deploying AI equally. Second is, of course, around responsibility. The makers of AI and the users of AI both have to both own the responsibility, and then we need to, as implementers, we need to ensure that through extensive testing and grounding of the models, we are able to get the right results, whether it's for the employee, the customer, or anyone. And then, of course, securing data from a data privacy point of view remains to be foundational. Now, of course, if you now start imagining manifestation of AI in autonomous cars, in India, of course, the idea is not to replace the driver, but to equip the driver with the best intelligence for safety. Unfortunately, India still has road fatalities. Even when the traffic is not high speed, even then there are much more road fatalities, and hence our focus is on putting AI on the edge in the car using cameras, LiDARs, and radars to making them safer. And all our cars are getting better and better in that, including the new launches, including electric cars. Of course, electric cars have a lot more AI use cases on battery management, range management, heat management, charging management, etc. But automobiles being safer is the core pillar. Secondly, and hence their data privacy, data confidentiality, and responsibility, that the car behaves in the right manner with AI and helps the driver and the passenger in the car to be safer. Similarly, lots of work in the rural ecosystem equally. We are large tractor makers across the world, but in India especially. And the opportunity there is to bring together soil data, satellite data, crop data, farmer data, land data, in advising the farmer to get better from their size of land. India is sub-hectare average holding of land, and hence the use case there is for the farmer personalized advice on their crop. We have done around 100,000 acres of sugarcane advisory based on satellite models on advising farmers on when to harvest their crop. Similarly, in Telangana, advising chili farmers on how to use pesticide for better quality of their produce. So lots of use cases personalized to farmers and ensuring the crop and many other areas. Getting together weather, I think if you look at it, weather is the biggest disruptor of farm, and 50% of livelihoods in India, because of agrarian economy and people living in rural, is dependent on it. And similarly in lots of other businesses as well. But I wanted to continue to focus on manufacturing, automobiles, and farming, and then, of course, in Mahindra Finance, or a finance business, around driving financial inclusion. Again, the data there is more secure and more personal, and hence how do you extend lines of credit to needy, especially if they're new to credit. which means they may have a bank account but never had a loan, or they may not even have a bank account. So how do you, in the deep rural and semi-urban, how do you judge ability to pay and intent to pay so that you're able to extend credit lines? So lots of use cases, I think, with DPDP coming in enforcement, it makes sense that all of us take up the responsibility to secure data and act responsibly and test the AI model we are using from a responsibility, explainability point of view. So that's our mission, and that's how we're doing it across all our industries.
Thank you so much. So now over to you, Professor Ravindran. Well, actually, maybe we could. Since you will be coming from an academic perspective, we can go move over to you, Mr. Anand, and you can give us another perspective on application and security in enterprises. Yeah.
Thank you, Tarunama. My name is Anand Kashyap. I'm co-founder and CEO of Fortanix. We are a Silicon Valley-based cybersecurity company. Thrilled to be here in India, attending the AI Impact Summit, and thank you everyone for joining. So what we do is securing data and AI, and we do that using security built in both in the software layer and the hardware layer. We are one of the pioneers of a technology called confidential computing. Confidential computing, when we started the company about 9 years ago, was a relatively unknown term, but has gained traction in the last few years. And as the awareness of the technology has increased, availability in the chip as well as in the cloud environments has increased. And the use cases that now we are able to address using the technology that we've been working on for the last 9 years has become extremely important in the age of AI. So when I see the topic responsible AI and how do you operationalize it, security is on everybody's mind, especially here in India as well. Things like data security, data privacy, sovereignty are extremely important. And to be able to do that using not just a legal or regulatory framework, but being able to do that by technology and making it seamless for everybody who's using the technology, that's very important. And that is what our mission is. So talking about AI, when you're deploying AI, there are, if you think about the security down at the infrastructure layer, there are two aspects to it. One is the security of the AI model itself. People are spending hundreds of millions of dollars to train these models, and the model builders are very worried about the model IP itself and the security of that. They don't want their models to be stolen. Model weights are sacrosanct to these kind of companies, right? On the other side, the people who are using the models, they don't just want to use the model with any generic data. They want to be able to bring their own proprietary data, enterprise data, to be used with these models. And then when they're doing that, they don't want to send their data all the way over to some server hosting the model in the US. They want to be able to send it closer to a server which is running the model in their own environment that they can control, they can see. So being able to protect on both sides, on the model side, as well as on the data side, securing proprietary data as well as securing proprietary model becomes extremely important. So we have partnered with NVIDIA and become a part of, an integral part of the NVIDIA AI Factory tech stack, where we are providing encryption, key management, and confidential computing to secure both the proprietary data and the proprietary model. And the implications of that are great. Being able to deploy AI with confidence in the Indian context, where we'll see a huge boom in the build-out of the AI infrastructure. And that is why we are excited about partnering with the stakeholders in the Indian ecosystem who are building AI and taking it to the next level in the next few years.
Okay, thank you. So we've had two voices from industry, and now we'll hear from Professor Ravindran, who is the scientific appointee to the UN committee.
I speak in my personal capacity.
I see. Sorry. But well, yes, Professor Ravindran is very accomplished, leads Sarai, the Badwani School of AI and Data Science. And so over to you. Yes, you can speak on a range of issues, but I think you had mentioned contextual safety.
No, that's fine.
Yeah.
No, I'll actually step back. So this panel is on responsible AI and operationalizing principles, right? So one thing we have already heard about, one of the key concerns that's there in the industry is about data security and model security and so on and so forth, right? But from the Center for Responsible AI, which I head, right? So we are actually worried about a few more issues, right? So the question is not just about the data security. The question is about, okay, how can you trust the model itself? The model is giving you some output, right? So how is it that you're going to actually accept that the output of the model is correct, right? So you would need to have some amount of assurances about that itself, right? So when we say we're talking about responsible building and deploying of AI models, it is about giving that confidence, that trust to the end user, right? So that they know that they can, trust the decisions of the AI system. So let's say there is an ADAS model, right? So you don't want an explanation at the individual level of why are you asking me to turn left or turn right or whatever. I mean, you're following Google Maps directions. You're anyway going to do it, right? You're not stopping and asking explanations. But at some point, the Google Maps, it must have happened to some of you. I've had it happen when it has actually doesn't even know about a bridge that was under construction that was completed. So it just tells you, no, you can't take a left here. You keep going straight. And I have actually driven around Delhi for like 7-8 hours extra because I missed one left turn somewhere. And if you're coming to Bharat Mandapam today, it will be 12 hours extra, I tell you. The traffic outside is insane. But anyway, the point is, at some point, you want this assurance that, hey, I know that the AI is doing well. If I go ask it an explanation, it's going to give it to me. So that is one part of it. The other part of it is about, when it's making decisions, is it being uniformly correct? Right? And when it is being incorrect, is it being incorrect in a systematic manner, which is a cause of worry, right? If it's going to say, let's say we're talking about a loan advisory for an agri setup, right? So if it's going to deny loans for certain farmers who are involved in a particular kind of crops, right? Then that is a challenge here. Either you should tell them, hey, you have to change your crop, that's why I'm not giving you a loan, or you have to, somehow the person who's debugging the system has to figure out that, okay, there is a systematic bias in the system that we have to address, right? So people can tell you there are many reasons for it. It's coming from the data. There's actually the socioeconomic reason for it because the whole world is biased, right? And therefore, the system is also biased and so on and so forth. But that's not a get out of jail card, get free card, right? Because even if the system is biased, when you start putting it in, building an AI model, right? And then you're saying, here is an automated system, like everybody can download this and deploy it and so on and so forth. You are now giving official institutional sanction to the bias, right? So you have to make sure, individual biases are one thing, but when you start putting it into an AI model, you are institutionalizing the bias in some sense. So we have to be very careful about addressing that. So some people jokingly used to ask me earlier, so you mean to say we need to hold AI to a higher standard than humans? Yes. Because of the inherent, unfortunately, there's an inherent trust we have for automated systems. They are emotionless, they can't be biased, it's a machine, it's as emotionless as a machine. So now when you say that AI is a machine, of course, don't say that I'm saying AI has emotion. I didn't say that. It's just that we have an inherently higher level of trust when you say that there's an automated system that's making decisions, right? So we have to be cognizant of that. So there are so many of these issues that we need to take into account, right? So, and the whole panel is about operationalizing these, right? So what does it take to operationalize this? The first thing that takes to operationalize this is to even understand what is it that can potentially go wrong in the system, right? So Tarunima's group does a lot of work talking to people who are getting affected directly by mistakes made by automated systems, but nowadays it's more focused on AI. So, she will talk about it later. I'm playing the role of the moderator when she's going to speak, so I'm just giving her a lead in. But that work has to be done across every sector, right? It could be driving, right? It could be driving. So, for example, suppose you know that your autonomous driving system makes like 0.1% error, right? Now the question to ask is that 0.1% error? What is the cost for it in driving, right? Is 0.1% error fine? Is it acceptable, right? Maybe in some kind of situation, 0.1% error is acceptable. But in another kind of situation, 0.1% error can potentially lead to, unnecessary undesired consequences, right? So I remember this. My PhD advisor once was telling a story about how he was using one of these electric cars, early generation electric cars, and he had it on some kind of autonomous assisted driving thing. Suddenly, in the middle of the road, it started accelerating, and the car was not even responding to him hitting the brakes. I have to be fair. This is like 12 years ago, okay? So technology has improved significantly, but it didn't respond to him hitting the brakes. So finally what he did was he drove over the divider, the median, so that the car eventually slowed down and stopped, because at some point it just couldn't make progress, it stopped. And then he had to get out and get a different vehicle and call for roadside assistance. They later figured out that that particular model, that the software that had shipped out with the model had a bug. He was lucky. Right? He was lucky that he managed to stop the car, but that could have been fatal, right? Now, this is not even AI. This is a software bug I'm talking about. Now, with AI, this can become even more complicated, right? So you really have to understand this, and this work has to be done in each and every discipline in which you are applying AI, right? In fact, I don't know if people have looked at the AI governance guidelines. One of the recommendations that we have given in the guidelines is to start doing a risk mapping for India in each and every sector. Don't blindly just assume risk categorization that has been done by the Europeans or by any other society. We have to start doing this exercise in India. So, and do this on a sector by sector basis, and then identify what are all the potential risks. And then we have to look at, what would be an appropriate reporting mechanism. So when some of these risks get actuated, or some unforeseen risks get actuated, how would people report these? So some kind of an incidents reporting mechanism has to be in place. Then you'll have to think about what would be the redressal mechanism once these incidents get reported, or these one-off incidents because of the inherent stochasticity of the model. We say, okay, yeah, this is never going to happen again in another million years. Or we are going to say, oh, okay, that's an important condition. So we need to figure out how to fix it and how to regulate it. It could be a legal answer, it could be a technical answer, it could be a sociological or a policy-based answer, whatever it is, but we have to do that exercise. There is no easy answer to this. But the potential of AI as a transformative technology is so high, right? We need to do this hard work to make sure that we are able to operationalize responsible deployment of AI. We'll stop here. And Taranima, please, over to you.
Okay, thank you, sir. So we have heard a couple of different strands within operationalizing. So one is more on the data and infrastructure side of securing data, having sovereign control over models, because that's part of the trust. Then another clear strand that's emerging is that the risks are contextual. Our assessment of risks is contextual. Just for example, lending, since two of you have spoken about it, in the US, there is a certain kind of optimization based on racial demographics, which is illegal. Whereas in a lot of other countries, including in India, that is something that we often think of as a way of promoting inclusivity, right? We want to basically account for certain demographic factors to give loans. And that's not just between India and US, that's also true with Europe. So we have different norms around certain automated decision-making systems. We also have different definitions of illegality, right? So for example, crossing, jaywalking, which is like crossing a pedestrian crossing in India, something we all do, right? I mean, if we all were to wait for cars to stop, I think we would not be able to cross roads in India. But that's something that's fairly strict outside, right? And that's the kind of thing that if you are doing self-driving cars, assisted driving, you would have to take care of that. So I would like to just maybe break these into two separate discussions, and let's talk about the data sovereignty or the data localization piece first. So I'd bring this to Mohit and Anand, right? Which is that you mentioned, so Mohit, to you the question would be, how much of your AI development is in-house? How much of it are you willing to rely on foundational models, AI systems that are being developed? How do you do that decision of procuring from externally versus developing in-house? And then after that, Anand, would love for you to come in on, how do you do that assurance where you've said that you do this firewalling so that your models are trustworthy and your users feel like their data is not leaving the premise? I understand the second part is easy, but how do you actually make sure, considering I assume you also don't have insight into what's happening in the foundational model, right? That how do you make that assurance to your users that this model is safe? And then, sir, I will, based on that, would love for you to reflect on their comments.
So I think the use of the word AI has become prevalent more in the last 2-3 years, and hence everybody imagines AI to be the Gen AI version, and hence we talk about foundational models, but AI is predictive as well. And in all the examples of lending in finance or the self-driving car or making cars safer, we're not doing self-driving, making cars safer do not involve generative AI. So all of those are predictive AI models where it's 100% explainable. And we have to ensure that it's tested fully, and we have to ensure that the data being used does not carry the bias which Professor was talking about. And hence, that responsibility is on us. So that's one part of the answer. Where we are using Gen AI, their grounding of data and seeing that we are not infringing copyright and protecting intellectual property is equally important, especially if it involves customer data. And we're doing lots of that by containerizing it, tokenizing it, similar to what Photonics also does, and maybe he'll talk about it, in helping it, using public, private key, cryptography, etc., so that data is then consentful and traceable across data at rest, data in motion, and you're able to do the data lifecycle management as well. If the customer opts out, you should be able to delete the data or not bother the customer again, etc. And that law has come up on the DPDP, and we're doing that as well. So what I was trying to get to is that your question on build versus buy, lots of the model in the core businesses are built based on data machine learning models, which are built. And they are more explainable than generative AI models. And hence you have to figure out where you use what. And where we're using Gen AI model, they're a lot on assisting either the customer or the employee to drive productivity, efficiency, and go faster. Like all our shop floor supervisors have a Gen AI assistant which can help you manage any defects on the shop floor so that the mean time to repair or the mean time between failures in the shop floor are minimized. So if a particular machine is showing symptoms of some error code, you can quickly put it in. You don't have to read the manual. It can tell you instantly, reset this pump, or this fuse is blown, or whatever. And that's helping higher availability of machines in manufacturing. Similarly, our car service centers, they have AI assistant so that when you give your car for servicing, it gets fully done faster, and you're not struggling with a particular problem, etc. So those AI use cases are not life and death, but they help bring together lots of digitized data and apply language in Gen AI models to advise that engineer who's already very good to become really good in solving problems. So lots of that is happening together. And hence what I was trying to say is that it's a mix of predictive AI and Gen AI together, which makes the case better in the use of AI. Now, of course, data to be localized and sovereign AI, those are important elements. For us, Mahindra being an Indian company, in Make in India, I think lots of it is already housed here. But that's the way I see it.
Okay, so the question to me was, in the context of securing data and model, understanding that how you can secure data is easy, but how do you secure the model? My question back would be, can I get a whiteboard? But the answer is probably not, because it's much easier to explain that way. So let me try to explain it in words. Okay, so what we are, so there are three different constituents in this. There's a model builder, there's an end user who wants to use a model, and then sometimes there's also a third interested party, which is a service provider. And this could be a telco, this could be a neo cloud or a GPU farm where the models are hosted, and enterprises would just rent space or rent access to AI models running over there. So these are the three places where a model can run. And there are two types of models. There are models which are open weight, where the model provider doesn't really care so much about the privacy and the security of the model. The model is open. But then there is a class of proprietary models, OpenAI, Anthropic, and there are a bunch of them. For them, securing the model is extremely important. So the current state of the art is model companies, the big model companies, they build their own infrastructure where they have full control, 100% control. They put the perimeter security, and they run the model in their own environment. And anybody who wants to use the model, you get API access, and then that's how you use the model. But when it comes to the end user, they don't want to send their data to the model, right? So there is a lot of demand from end users, from the service providers to host these models. And for the model providers also, this seems natural that they want to be able to give their model to the service providers sovereign AI providers or end users. And this is where the technical part comes in. So we have a design or a pattern, again, that we have built in partnership with NVIDIA, where we use a combination of cryptography and a technology called confidential computing to make sure that the model is protected end-to-end. Where cryptography comes in is the model builder, when they build the model, after building it in their CI/CD process or in their software development lifecycle process, they would encrypt the model weights, because the model weights are very critical. They need to be protected. They encrypt the model, package it as a container or a VM, then they would measure the model. So what measurement is, think of it like a hash of the binary of the model when it actually runs. Then they create a policy that the encryption key that was used to encrypt the model would only be released to the model for decryption at runtime if the environment where the model is running can prove that it is a secure environment. And this is where the confidential computing part comes in. Confidential computing is a technology for protecting data in use, not just at rest or in motion, but using the hardware, using the CPU, and now with the GPU from NVIDIA, you can create a secure enclave or a trusted execution environment where all the data and the code that goes in remains secure even at runtime. Nobody can look into it. If somebody wants to dump the memory, they'll get everything encrypted. So we use that technology. And if the model can prove that it is running in a confidential computing environment, if the hardware can be trusted, it has not been tampered with, if the software has not been modified, and this is where the measurements come into the picture, if the build time measurements match the runtime measurements, then our systems have a mechanism by which the secure key, the key that was used to encrypt the model, can be released to actually decrypt the model. And then the model weights can be decrypted, the model runs, everything is fine. So it kind of creates a closed loop system where the model stays encrypted end to end. And this is how the model owner can get the assurance that the model cannot be leaked at runtime.
Great. I was not expecting the technical answer, but this is actually very interesting. So, Professor Ravindran, my question to you is, when would you not trust the confidential computing? So, in what application? I mean, do you think that technology is foolproof? So that's one question. But are there certain use cases where you think that it is absolutely necessary that that model be entirely developed in-house, hosted in-house? The data, of course, the data doesn't leave. So, yes. Do you have a take on?
So in this case, in this instance, right? So the question. Let me try and rephrase the question so that I understand it fully, right? So your question is, okay. So what if you don't want to build the model in-house, but can you trust the model that is coming from an external developer, where the details are not disclosed to you because it is being completely protected by confidential computing? Or are you fine with using that model? When would you do that versus build something in-house?
So this is actually tied to what you had said about every sector needing its own sort of risk mapping, right? And we all recognize that there are certain use cases which are more sensitive than others. If, let's say, we had to look at it in the context of maybe not just an enterprise, but if we had to look at it more broadly in the context of public service delivery, right? I'm trying to link that point to the build and buy conversation, right? So if confidential computing works foolproof, is a foolproof technology, then we should all feel comfortable in some ways, maybe relying on some of these other models, but we don't. Right, so I'm asking you, what is your intuition for?
First of all, confidential computing is not used as widely as you would want them to be, right? I mean, this is that USP in some sense, right?
Sure.
So it's not that. Let me step back, right? So the fact that you want to trust the model, right, it doesn't actually quite get affected by whether you're using confidential computing or not. I mean, confidential computing really protects the proprietary knowledge of the model developer and also ensures that no malicious actor can modify the model in transit, right? And also that the third party is basically not being able to look into the model details, but is guaranteed that the performance is as good as if they had the actual model available to them. Is that a fair characterization?
Yeah, let me just second that. So that's exactly the case. So computational computing is a technology that will protect the privacy of the model. The model cannot be leaked, it cannot be stolen, but if the model itself is malicious,
Exactly.
it has been poorly created,
Exactly.
it
That's the
has
point I was coming
bias,
to. That's the
then
point I
there's
was
no
coming
protection
to,
against
right?
that.
So the trustworthiness of the model stems from how much you trust the model builder, right? So if that is going to be a case, then perhaps in-house building is the way to go, right? But having said that, there's a caveat here. How much can you trust an in-house model depends on your capacity to build the model well. Of course, the data is always there. Whether you give it to another person or you build it internally, the data is there. But internally, if you're building the model, it also depends on your capacity to build the model, right? I mean, how well do you understand it? Are you using the right model for it? I mean, you probably will have to bring in expertise from outside and so on and so forth. If you have a process by which you can, reliably build the model, test the model, to your satisfaction, and ensure that, all the corner cases that are unique to you are covered and so on and so forth, perhaps the in-house building is the way to go. But of course, as long as you're doing manufacturing and things like that, where you're not getting into the Gen AI domain, all of that is fine, right? So I think, and I do agree with what he said earlier, right? A lot of the real-life deployments you still see, right? Especially in the manufacturing sector and also in some of the other, financial domain and things like that, right? The financial domain has been using AI for more than a decade now, almost decade and a half now, right? So, and that is almost always, discriminative AI, right? Or predictive AI, however you want to call it, right? So, in such cases, I think the companies have matured, the industries have matured enough that they have internal capacity to build these models. But once you start talking about, hey, let's get into the Gen AI domain, right? Then I would say perhaps relying on external models that have been sufficiently tested with large amounts of data which are not available to you anyway, and then trying to build a trusted platform on top of it might be the way to go, right? But then you get into all kinds of other problems, like whether you have a sovereign model and things like that, and all of that becomes a challenge. So it's a function of, okay, how much you trust the builder, if it's an external builder. And of course, there are other ways of addressing this in non-critical sectors. You could have liability mechanisms, right? You could have guarantees, you could have SLAs, and so there are legal mechanisms, and there are other processes for ensuring some amount of trust, right? It's not always a technical answer. So that we have. So it's like I said in the beginning, it's not an easy answer, but we'll have to take into account all of these. Hey, you should be making some of your own points.
Well, yes, I was just going to come in. Thank you. With that, I'm going to segue into the second thread that had emerged from the opening comments, which was basically that we have varying definitions or often contextual risks that emerge. So now I'll give some background about our own work. I run an organization called Tattle. So, very briefly, we look at contextual risks in Indian languages. We look at multimodal content, and I'll focus this down to Gen AI, but some of the things, even with foundational models, the models we were saying that we would like to trust, actually their safety evaluations for the Indian context aren't at par at what they would be for English, right? So the same, for example, risks that might be detected in English, which would be asking questions about, say, self-harm, asking questions about committing certain crimes, where the models will recognize that this is a nefarious use case. Those actually don't get detected in a lot of Indian languages, right? So that's one kind of risk. And then the other kind of risk is that a lot of the issues that we might see in India, they don't even emerge as risks in other geographies, right? And that's true, of course, in all other countries as well. So there are certain contextual manifestations of risks, which are like the foundational models that we were just saying that these are models from big enterprises that we should trust. Okay. So I'll come back to it. Okay, yes. So I'll come to you with that. But basically, I think the question is that there is some kind of dependency that we all have on these big blocks, which a lot of countries or definitely a lot of enterprises will not be able to build from scratch because we don't have the data, we don't have the compute. And so considering that we are all, to some extent, reliant on these core building blocks, that are also not adequately tested for our geographies, how do we proceed? So that's going to be my next round of questioning, and Professor Ravindran, I'll open with you, and then I'll move on to the other panelists.
So, I mean, I've always been arguing that, yeah, great, the foundation model technology itself is amazing, right? But then I think, in some sense, trying to get the latest, greatest version of something that comes out of OpenAI or Google and trying to somehow make it work for your application is not the right way to do it. Right? So if you see what we have been having a lot of success in recent times is to actually what I call as right size these foundation models or right size these models, right? So basically look at a much, much smaller number of parameters, but then these are models that solve the problem that you have at hand. So there are several advantages to going this way, right? The first one is that, of course, you don't need that much compute power. Right? So we can actually afford to try and build these things. Second, you don't need that much data to train the model, right? Especially if you're in a very niche area, you probably have a lot more curated data than having to trawl the internet, in which case it does turn out that high quality curated data does reduce the data requirements for training these models for the same size, right? And the third thing, though, is something which people don't talk about enough. It's much easier to robustify these small models because they are going to operate in a very specific setting, right? So I can write filters to this saying that, hey, look, if the queries are going to go outside this narrow range of operation for which I have built this model, you can filter it out. And at the same time, I can also do output monitoring and be much more rigorously and say that, hey, look, there's something that seems to be deviating here. And I can also, control my output generation and whatever in terms of my RAGs or my runtime inference. All of these things become a lot more manageable, tractable, and repeatable when you're starting to talk about small models. It's only when you're talking about very large models which are trying to boil the ocean, right? So then you can get into trouble in terms of controlling the outputs and the inputs. So I think there are all these advantages for going with smaller models. And I think that's the right way to go. I mean, even if you are going to take one of these big models that are out there, yeah.
Model distillation, yeah.
Yeah, model distillation might be the way to go about it, but I have my own. We don't understand enough about how model distillation distorts the distribution of the data yet. I mean, I didn't want to get into technical things, so I just stopped.
Yes, I should also just control myself. But over to you, Mohit, and then I'll come to you, Anand.
I think 100% agree with the professor. I think lots of the edge use cases which are yet to fully unfold, while intelligence in the car to detect a goat and brake in advance is not dependent on the cloud or the LLM. That's already written for, where you train the data and it's loaded in the car on the edge. Yeah. Even if the car is not connected to the cloud for that instance because of the network going down, it still has to brake before the human being has seen the cow or the goat or whatever. And so many of those are yet to fully unfold, whether it's smart wearables, we went to the Meta gallery there, whether it's smart wearables or on the phone, and then the edge, multilingual and multimodal and edge, all that is yet to unfold, but that's the way to go, where the SLM probably, at least for the industry, most of the use cases are within the confines of the subject, not outside. So all I spoke about around shop floor supervisors or the service center mechanics, those are all SLM deployments because they're within the context of what they're asking. And hence, you don't need to have a LLM there. And the grounding, training of SLMs with our data leads to best results. And data we have plenty because digitization happened 10 years ago. Right? So it's application of AI now in the last 5 years. The digital age was maybe 10 years ago, and you have lots of manufacturing data, supply chain data, etc. So to me, that's kind of the answer, that it is a lot about explainable SLM and trainable SLM and training with your data so that it's hyper-personalized, localized, etc. And it's not just lift and shift and ported from some other part of the world. It is done locally in some way. Now, do you have to write the foundational SLM? May or may not be. But like I said, predictive AI, you do write the machine learning models. That we own. And they are much more easier to explain.
Yeah. I have a question about SLMs and security of SLMs, but after you go.
Maybe I'll just add one thing that a lot of times it's not just, when you're thinking of AI, it's not just a model, right? You're thinking of a system of models and you're building applications and use cases which are much higher level. I was in the expo floor in Hall 4. I saw a couple of Indian AI models, frontier models as well over there. And then I saw a demo where it was a speech-to-speech translation, but it's not a single model, right? It's speech-to-text, then there was an SLM after that, and then it was text-to-speech. So a lot of times there'll be multiple models which are working together to solve a use case. And some of them will be big 3 frontier models, but then there'll be a bunch of small language models, there'll be audio models, there'll be multimodal models, and then a lot of regional models running on the edge as well. So I think we're probably going to live in a world where there'll be hundreds, thousands, maybe billions of models.
Yeah, I have one final question before we do open up for Q&A, which is, any of you can take this, which is that as we sort of distribute the training process, as we go into small language models, that doesn't obviate the need to actually do stress testing, safety testing of these models as well, right? And so what are the organizational technical processes that actually make that possible? Because often when we do it in smaller enterprises, Professor Ravindran was saying you have to have the capacity to train the models. I also think you have to have the capacity to secure and make the models, the small language models, safe as well. Yeah, so what are the processes that all of us who are actually doing our own in-house training should be going with?
I think for us, it's a subject where risk, legal, and compliance are fully empowered and engaged. And it's not left to either the technology team or the business team to roll out whatever they want to, etc. And it's a bigger topic of ethical use of AI as well. Where not to use AI, right? That's very important. Roadside assistance, if you are, distressed and your car is broken down on a highway and you're in the middle of the jungle, that's the last time you want the AI to pick up the phone and quiz you on where you are, right? That's when a human being can give the empathy and help you a lot better. So where not to use the AI is also very important. So that we have clearly set guidelines on where to use what kind of AI and where not to use AI. So to me, it is a multi-function champion-challenger model, at least in our use cases, in the enterprise, that you have to have a champions of AI and challenges of AI. And only if it passes that test with adequate testing and sign off, then you go ahead. So that's kind of my short answer.
Yeah, I mean, sure, but that also requires you to have actually developed the institutional capacity to have said that, right? So it's a tough question. So one of the things, so let me pitch something that I just spoke about in the working group a little while ago. One of the deliverables that we are trying to get out from this summit is this, what we are calling as the Trusted AI Commons. It's like a collection of tools, benchmarks, protocols for testing, verifying AI models that's particularly focused towards the Global South. And they're also potentially connect to the use case commons that's also being set up, so that for specific use cases, how did people go about doing the testing? Not just showcase the success of the model, but also showcase, also make available the resources that went into building this model and so on and so forth. So resources like that are very important. And of course, the more it is in the open source, the more usable it becomes for developers across the board. So even if you don't have significant internal capacity, but if somebody has actually built a model, then they should at least be able to dip into these collection of tools and do the testing and so on and so forth. But it's a challenge. If you don't have internal capacity, it is a challenge. You'll probably have to work with an external partner to do that. Yeah.
Yeah, I think Professor Ravindran and Mohit have already covered most of it, but the whole thing is, before a model gets deployed in production, it has to go through a thorough testing, and it will have, and for that, they need to develop the benchmarks, right? And the benchmarks, some of them are traditional software benchmarks, right, around performance and safety and bugs and things like that, but a lot of them will come through this new framework that is being designed here in India. We've seen some in Europe from the EU AI Act, and a combination of all of these. So what we'll see, and we're already seeing that in large enterprises, before models get deployed in production, it goes through all these testing against benchmarks based on regulation, compliance, safety, security.
I am going to open to audience right now, but I will conclude by one thing using my sudden moderator privileges, which is that one would assume that enterprises and public sector does some kind of testing, but we've seen enough use cases in the last few months. Notably, I think Gap had a chatbot, which one would expect that they had done adequate testing. It just within day of launch was spewing all sorts of nonsense. We see this with a lot of social sector applications, organizations we work with, where one would assume that they would have done some testing, but we're often the first ones to have looked at their data months after they have deployed, right? So actually testing is far less common than one would hope. And yes, if we have common resources, one hopes that would make a difference. Okay, with that, we're going to open it to the audience. Is there someone who can walk around with a mic? Yeah, you.
So very quickly, while the mic is going out, I just wanted to tell you, one of the reasons adequate testing doesn't happen, especially in Indian deployment, is that we don't have data to test it on. Even if I want to test it, I don't know what to test it on. Okay. Right? I mean, all the benchmarks and everything is, all geared towards, I mean, some of them are geared towards solving math Olympiad problems, which we don't want, but even others are mostly English focused and or talk about cultural sensitivities in the West, not in India. So that's something that we have to do.
You can ask AI what to test it on.
No.
It'll tell you things that it is very good at, right?
Okay, so I think this is just to make this more efficient. We're going to do 3 questions and then move it to the panel rather than question and answer. So that makes it efficient. I saw a bunch of hands. So we can take your question first, please. Yeah.
Okay. First of all, thank you for very useful information. I have 2 short questions. First one is, as per EU AI Act, so they are very stringent on VAI, verifiable AI. So what is from an Indian government perspective, are there any policies on that? And second one is, like normally we say, if you have ISO 27001 or IEC certification, then we get some natural trust in the provider. So is there any certification coming, especially for AI models?
Great. Okay, so those are 2 questions. Can we, move to you? Yeah. Can you try just speaking up? We can hear you. No, there's someone behind you. Yeah.
Check. Okay, so wonderful discussion. My name is Ikansh, and I'm an aspiring researcher. And I have to ask, Professor Balaraman, you did discuss how during AI inference, there continues to be a need of human in the loop, and there continues to be a need of AI inference. However, by the early 2010s, there was an article by Richard Sutton, if you know, called The Bitter Lesson, emphasizing how over the research history and even from time immemorial, from the beginning of traditional statistical models all the way to the current Gen AI applications, our models continue to be restricted not only by the knowledge that we give it, but also the constraints that we give it as well. So human constraints continue to constrain the performance of the model as well, instead of letting it invigorate new solutions on its own. So how can we apply those principles to a more inferenced and explainable context as per you?
Okay, so we'll take the 2 questions. I see 4 hands. Okay, so Professor Ravindan, you can go first and then others.
Sure. So let's start with the thing. So there is a lot of efforts globally to build AI standards. So ISO already has some. IEEE already has some standards now out there, but they're all more about AI model life cycle management and things like that, but not necessarily on the quality and testing of the model yet. So the standards haven't come. But there is a global group, like it's called LTD30, that's been discussing this very actively on trying to figure out what should be the standards for for AI models. And India has been a very active participant in those discussions. So it'll come, it'll evolve, it'll take some time. But the challenge, of course, is because the technology is also moving so fast, right? So where do you draw the line? But we have to start somewhere. So I think those standards will certainly come. I'm sorry, I don't recall what the first question was. Verification. Yeah, sure. I mean, if you notice the latest revisions to the EU Act, they are also walking some of these things back. They knew that they were asking for things that were not possible. In fact, there was a study that said that the extreme stringency of the EU Act significantly damaged the AI startup ecosystem in Europe. So they kind of are beginning to realize the harm of that. But having said that, yeah, of course, you need some amount of verification, right? So from a computer science point of view, when you say verification, it means something very different. It means a formal proof that the model will work right. That can never happen, right? Because the very nature of the technology is such that you cannot give a guarantee on what will the model do on completely unknown, unseen data, previously unseen data, unseen circumstances. I don't even call it data. On completely unseen circumstances, we don't know what the model will do, right? So. Having some amount of testing validation is important, and I think that is being done by at least the big enterprises. They try to do things to the extent possible, but not always. Like as Tarima was pointing out, there have been instances where things get, in fact, ChatGPT itself was something that's put out a lot of enough testing. But anyway, so we know that happens, right? So it's something that has to evolve over time. So it'll happen when you start having, I'm sorry to have to fall back on market forces, but if your model is failing so often, then people will stop using it. So you'll have to actually start testing it. I mean, that's the only way to start enforcing this, because we don't have legal recourse that can act at that with that agility for us to do this. Going back to the inference question, so human in the loop is very different from what Rich was talking about in terms of the bitter truth, right? So in terms of bitter truth, he was talking about, hey, we did not learn how to fly by watching a bird flap its wings, right? So it's not that we need to actually imitate what humans do or what nature does in order to build on top of it and do better. So that's what he was talking about. By the way, you should look at his more recent essays and videos on after he got the Turing, right? He's become a lot more he's saying a different thing now. It's not quite the bitter lesson anymore. So when I have human in the loop, I'm talking about a human supervising the output of the AI, not necessarily the human making the decision, right? I mean, the human is supervising what the AI is doing, and so the AI can be built with whatever technology you want. It could be a transformer model, right? I don't think anybody in their right mind is saying the transformer is a model of how the brain is functioning, or whether the transformer models were inspired by the brain's architecture or anything, right? So we have gone beyond that right now in terms of whatever is the cutting edge AI, and people still believe that this is going to get them to Gen AI or whatever, right? But when I say human in the loop, it doesn't mean I'm restricting the architecture or I'm restricting the training. So it's more about the reliability of the AI input at this level of technology that really requires us to have the human supervision. That's what I was talking about.
Okay, Anand, would you like to quickly come in on the verification or the certification question? And then I think we'll have time for maybe 2 more questions at most. But quick, blitzkrieg. Yeah. We don't have time. I see. Okay. So this is your final comments if anyone wants to close. I see. Three. Yeah. Do you want to say anything?
Maybe I'll just add to what Professor Ravindan said. Nothing on the verification side, but on the constraint put by the human in the loop. I'm not an AI expert or a researcher, but I'll regurgitate some of the things that I've heard others say. So when people talk about constraints like human in the loop, it's not really constraining the architecture, as Professor Ravindan said. I saw Jan LeCun walking the halls just a while ago, but people like him have been saying that it's not just the architecture itself has some inherent limitations, and a new class of models will eventually evolve if you really want to do science, if you want to do physics. And a lot of times, you have human in the loop also because you want to be able to ask AI what the right questions are. So AI itself cannot come up with the kind of questions that need to be asked if you really want to go to the next frontier and solve science. So those are the things people are still working on. Thank you.
Okay, thank you. Thank you so much. We are at time. You can find them outside. And no? Okay, a lot of them are running away. So good luck finding them outside. But thanks everyone.
Thank you so much for this wonderful discussion. I would like to present a small memento, moment of appreciation from India AI team.
All the photos that I'm picking up.
Thank you.
Thank you. So you can go for your next one.
So next session will be at 2:30. It will start at 2:30. So please vacate the room who don't want to attend this session. Next session will be at 2:30. Hello.
this thing.